So this is 3.1. Oh, and we'll get a new seating chart. I just haven't gotten it taken care of yet for chapter 3. And I'm just going to call this lesson parallel lines. All right, so the first thing we need is a little bit of terminology, some definitions. Well, the first one we talked about already. And I'm going to add just a little more detail. In the plane. So if we're on a flat surface, in the plane, parallel lines do not intersect. Like we said, that's the main idea with parallel lines. In space, in 3 dimensions, parallel lines also don't intersect. But in space, we have another way that lines may not intersect. We can have what we call skew lines. Skew lines don't intersect. And are not parallel. So the way I think of skew lines is kind of like this. So if we think of the upstairs C-wing hallway and the downstairs main hallway, those 2 hallways don't intersect, but they're also not parallel. They don't go in the same direction. So we call those kinds of lines skew lines. If a plane's flying in a level flight overhead, it's not going to intersect a car that's driving down on the ground, but those 2 paths are not necessarily parallel. So we call those skew. So sometimes things are different in 3. We have additional things that can happen in 3 dimensions versus 2 dimensions. All right, the last piece of terminology that we need before we start filling in a graphic organizer is we're going to talk about transversals a lot in this chapter. A transversal is a line, a segment, a ray that intersects 2 or more parallel lines. So what we're interested in today is what happens when a transversal intersects 2 parallel lines. And lots of nice things happen. All right, we all good? Okay, let's start working on our graphic organizer. I'm going to draw a picture here that is going to look more or less like the one that's on your graphic organizer. And I want to talk about some symbols first. So it says this is line M, this is line N, this is straight on your graphic organizer. This is line L. And if you notice on line M and N, they have 2 arrows like this. We use arrows to show that the lines are parallel. So those arrows that the lines are parallel. So just like we use tick marks for congruent segments or congruent angles, lines that have the same number of arrows drawn on them like this are parallel. So when we draw a picture, that's how we're going to know that lines are parallel. So don't confuse the tick marks with the arrows. The arrows mean parallel, tick marks mean congruent. And we write line M is parallel to line N. So the two vertical bars mean parallel. And it might help you remember if you think you can think of these as a pair of L's. Two small L's. So on this diagram, we know that line M and N are parallel. Line L intersects both of those. This is our transversal. And I'm going to number the angles just like they are on your graphic organizer. And what we're interested in is how these angles are related. One other piece of information, and this is how we're going to refer to the angles. Between the parallel lines, we call the interior. So when we're between the parallel lines, we're on the interior. Outside the parallel lines, we call the exterior. So out here is the exterior, out here is the exterior. All right, so we all have those little details that we can put on our graphic organizer. All right, let's start with the top box there in the middle. It says corresponding angles. Corresponding angles, what I'm going to do for each of these angle pairs is I'm going to list the angles by the numbers that are that are corresponding. So we'll do that for each box. So on your graphic organizer, angle 1 and angle 5 are corresponding, and we're going to put a relationship in here in just a second, so you want to leave a little bit of space there. Angle 4 and angle 8, angle 3 and angle 7, and we have one more pair, angle 2 and angle 6 are corresponding. So let's look at those. Angle 1 and 5, angle 2 and 6, 4 and 8, 3 and 7. So just based on their appearance, let's just pick one. Let's look at 1 and 5. How would you guess their sizes compare? This angle versus that angle? Or let's look at 2 and 6. This angle 2 versus angle 6. How would you guess they're related? Well, these are both. They're both acute. Angle 1 and 5. So it'd be hard for them to. Those two couldn't be supplementary, right? Just how do they look? What do they look like? They look like they'd be congruent. That's how they're related. We're going to say angle 1 is congruent to angle 5, 4 is congruent to angle 8, etc., etc. Corresponding angles are congruent. So those 4 pairs of angles, when we have parallel lines and transversals, are congruent. The way I think about corresponding angles, in terms of how they're positioned, of course, they're kind of in the same place. So angle 1 is to the right of the transversal and above the parallel line. Angle 5 is to the right of the transversal and above this parallel line. They're in the same place. If I moved this X with all the angles over here and laid it right on top of this X with all the angles, angle 1 and 5 would be in the same place. Angle 2 and 6 would be in the same place. So that's how I visualize, one way to visualize corresponding angles. All right, so this would be the information, the important piece of information to have in the box that says corresponding angles. Which ones are corresponding and that they're congruent. All right, let's move to the left. In the box it says alternate interior. So the alternate interior angles. Alternate means opposite sides of the transversal. Interior means between the parallel lines. So our alternate interior angles are angle 2 and angle 8, and then angle 3 and angle 5. So alternate means opposite sides of the transversal. Interior means between the parallel lines. So looking at those, 2 and 8, 3 and 5, how would you guess the sizes of those compared? So if we look at angle 2 and angle 8 there, or angle 3 and angle 5 there. Just what would you guess? What was that? Any guesses? No one wants to guess? Those angles are going to be congruent. So when we have two parallel lines cut by a transversal, alternate interior angles are congruent. And again, alternate, opposite sides of transversal, interior between the parallel lines. All right, let's move to the right and talk about alternate exterior. And I'm not going to label this one like we did last time. Alternate, again, means opposite sides of the transversal. Exterior means outside the parallel lines. So our alternate exterior angles are angle 1 and angle 7, and angle 4 and angle 6. So let me go back to our picture. 1 and 7, opposite sides of the transversal, outside the parallel lines. 4 and 6, opposite sides of the transversal, outside the parallel lines. So by their appearance, 1 and 7, 4 and 6, how would you guess those are related? They're congruent. So our alternate exterior angles are congruent. All right, let's move down to the left. Same side interior. And the other way that you'll see these referred to is consecutive interior. Same side means same side of the transversal. Interior means between the parallel lines. So on our diagram, that's going to be angle 2 and angle 5, and angle 3 and angle 8. So let's go 2 and 5, 3 and 8, same side of the transversal between the parallel lines. And let's come up with a guess about how those are related. Well, angle 5 looks like it's acute, and angle 2 looks like it's obtuse. So these are not going to be congruent, I don't think. Any guesses? What? Supplementary. That's a good guess with an acute and obtuse angle. Those two are going to be supplementary, those pairs. So I'm going to say the measure of angle 2 plus the measure of angle 5 is 180. The measure of angle 3 plus the measure of angle 8 is 180. So same side interior angles are supplementary. So we have some pairs of congruent angles. Now we have some pairs of supplementary angles. And let's finish up with our same side exterior. So same side of the transversal, exterior, outside the parallel lines. So those two pairs are going to be angle 1 and angle 6, and angle 4 and angle 7. So let's look at those. 4 and 7, 1 and 6. Well, one looks acute, and 6 looks obtuse. 7 looks acute, 4 looks obtuse. So, want to make a wild guess on how those are going to be related? Supplementary. Those are supplementary as well. So I'm going to say the measure of angle 1 plus the measure of angle 6 is 180. And the measure of angle 4 plus the measure of angle 7 is 180. And those are going to be supplementary. So when two parallel lines are intersected by a transversal, we have a bunch of angles that are congruent, a bunch of pairs of angles that are congruent, and several pairs of angles that are supplementary. So we only have two relationships that we need to know, but it's important to know which is which. They're either congruent or they're going to be supplementary. Our book uses this same side interior angles are supplementary as our postulate for parallel lines. We have to start with a postulate, something that we're going to accept as true. The rest of them then you can prove as theorems if you take this one as your postulate. Different books use different ones as a postulate and the rest are theorems. So one of these things that we said has to be what we accept as true without being proven, and then the rest we can show are true if we accept the first thing as true. All right, so questions about our angle pairs that we talked about, same side interior, alternate interior, etc. All right, we have two more boxes on the front side of that graphic organizer, and these are more just reminders at the very bottom. Because when we have lines intersecting, any lines intersecting, we have vertical pairs. Well, we already know about vertical pairs, right? What's true about vertical pairs? Let's remember what a vertical pair. Vertical pair means they cross the x from each other. So what do we know about vertical pairs? We talked about those in chapter 1. 1 and 3 is a vertical pair. 5 and 7 is a vertical pair. What's true about those? Yeah. They're congruent. Vertical pairs are congruent. So in your blank, vertical angles are congruent. And then finally, when lines intersect, we also have linear pairs. And again, a linear pair, two angles that make up a line. So 1 and 4 is a linear pair. 1 and 2 is a linear pair. 3 and 2 is a linear pair. What do we know about linear pairs? They make a straight line. So what about their measures? They add to 180, so they are supplementary. Good. All right, so that's our other reminder. Linear pairs are supplementary. So when we have intersecting lines, we have vertical angles. We have linear pairs. If the lines are parallel, we have these relationships with the alternate interior angles, same side interior angles, corresponding angles, et cetera, et cetera. So we can figure out a lot of information when we have intersecting lines, and especially when the lines are parallel. All right, so questions on that first side of our graphic organizer. Okay, I want to do a couple of examples, and these examples are the kinds of things that we're going to practice on with our whiteboards. So the first one, I'm just going to draw a pair of parallel lines and label some angles, and I just want us to identify what kind of angles they are. So numbered a little differently than our graphic organizer, and I'm going to put the arrows there so we know that those lines are parallel. All right, so for the first examples, I want us to figure out just what kinds of angles they are. So we're just naming them. How about angle 3 and angle 5? 3 and 5. What kind of angles are those? What is it? Alternate, because they're on opposite sides of the transversal, and interior, because they are between the parallel lines. So those are alternate. I'm going to use an abbreviation, interior. How about angle 1 and angle 5? So what you can do is look at these angles and match them up with how they're situated on your graphic organizer, if that helps you. Well, they're definitely on the same side. 1 and 5 are on the same side, but one's inside and one's outside. Corresponding. Those are corresponding angles. And that's one way to help you remember corresponding angles. Corresponding angles are the only pair of angles that we talk about with parallel lines where one is on the inside and one is on the outside. How about angle 3 and angle 6? Are they alternate or same side? Same side for sure, right? Interior, exterior. Interior. So same side or consecutive interior. Let me see if I can be tricky here. Angle 5 and angle 7. Vertical. Nice. 5 and 7 are across the intersecting lines from each other. Those are vertical angles. How about angle 5 and angle 6? They're linear pair. Let's do one more. So with the whiteboards, we'll practice on this kind of thing. Angle 1 and angle 7. They're exterior, definitely on the exterior of the parallel lines. Same side or opposite sides of the transversal. Opposite, so we call them alternate exterior. Okay, questions there? All right, this last example, I'm going to draw a couple of parallel lines, and I want us to figure out all the angles here. So I'm going to say 1, 2, 3, 4, 5, 6. So we know that this angle is 130 degrees, and we want to figure out the rest. And I want you, when you figure it out, tell me how you figured it out. All right, so who can help us out here? Yeah?
1, 3 are also 130 degrees.
5, 1, and 3. So how did you figure out number 5 was 130?
Because it's linear. Or no, it's
Vertical.
130.
And 1?
That's
We could do that one a couple of different ways, right?
yeah, it's the exterior
Alternate exterior from this angle. Or if we figured out that this one was 130, it's corresponding to that one. So we could figure out a couple different ways. So both of those angles are 130 degrees. What else can we figure out? Who else can? Yeah. Sybil.
So therefore, 2, 4, 6, and 8 all must be 50.
2, 4, 6, and 8 have to be 50. 2, 4, 6, and 8 are all 50. So how did you start on that one?
Well, first off, 30. Well, first off, 8 and 100, and the angle that's 130, I think that's angle 7. Are both supplementary.
Supplementary. They're a linear pair.
So therefore, 8 is 50.
Uh-huh.
So therefore, the 6 is 50.
The vertical.
And so therefore, what? And so therefore, 4 is 50 because alternate interior.
Mm-hmm. Nice.
So therefore, 2 is 50 again.
Vertical. Yeah. So you can kind of zigzag through. We could also say just a couple of other ways to think about it. Once we figure out this one is 50, well, 8 and 4 are corresponding, so that has to be 50. 8 and 2 are alternate exterior, so those are congruent. So with your parallel lines, once you figure out an angle, you can figure out all the rest. And it's nice because you have several different ways that you can do it. There's not just one way to do it. All right, we have one angle that we haven't figured out yet. What is that one going to be? 130. And there are lots of ways that we could have figured that out. Corresponding, linear pair, same side interior, vertical. So lots of ways that we can figure that out. All right, questions there? Okay. This is our homework. So what I want to do, I'll answer a couple of questions about the algebra review. We'll collect those, and then we are going to we'll do some whiteboard practice with some of this vocabulary and angles. All right, there's that.